Hello wonderful person, this is Anton, and yesterday we talked about Vesta. Today we're going to be imagining a situation where Vesta, and I guess the rest of the asteroid belt, actually does become a planet. Let's discover what kind of a planet we would get if Vesta were to become an actual planet. Welcome to What the Math. So in one of the previous videos I talked about several ancient astronomers, or I guess they're not really ancient, the early astronomers from the 18th century that speculated that there was a planet that would be located in the asteroid belt based on very simple mathematical calculations that they came up with. Now today we know that there should have been a planet, but because of Jupiter there is nothing. But today we're going to speculate and imagine a situation where Jupiter does not influence the asteroid belt and the asteroid belt actually does create a legit planet, a planet that is or was supposed to be created here. How big would it be, and what kind of a mass would it have, and what kind of a composition would it have? So first of all, we need to actually do a little bit of math here and calculate what is or what would be the total mass of this planet. We know that Ceres is the most massive object in this region, and its mass is approximately, I think it's like 1/100th of the moon. And in terms of the actual composition, it's about 70% rock, the rest is most likely water. Now, this object is being the most massive, a good sort of starting point for us. And we know that if you multiply its mass by 3, you'll get most of the mass of the asteroid belt. So these scientists believe, though, that the asteroid belt used to be much more massive. And specifically, we think that about 99.9% of the entire mass of the asteroid belt was actually lost because of the influence of Jupiter. So let's begin by starting a new simulation here and essentially taking some of the larger asteroid belt members, so like Ceres, Pallas, and Vesta, placing them right next to each other, and, well, I guess colliding all of them into one piece first. Or I guess the easier way would be to actually just take the mass of Vesta and multiply it by 3, because that would give us approximately the mass of the asteroid belt. But this wouldn't actually be as much fun, so instead let's have some explosions here. Alright, so here come the explosions, not as dramatic as I hoped it would be, but good enough. So the total mass of the asteroid belt actually hasn't reached it yet. I need to give it a little bit more mass. It has to be about 3 times 10 to the power 21. This is the total mass of the asteroid belt. But this is only about 99.9% of mass missing. So we actually have to multiply this number by about 1,000 to get what would essentially be a good representation of a planet that would have been created in this region. Now I'm going to rename this to Vesta because we think that Vesta was most likely the more likely sort of protoplanet that should have been creating the planet. Just based on the composition, as I mentioned in the video yesterday, it could have been a planet if it wasn't for Jupiter. But Jupiter caused it to not be a planet. Now, having changed the value and multiplied the value by 1,000, this is what I get. An object that's about 41 masses of the moon, or approximately half of mass of Earth. Now, it currently looks a little bit too extreme, maybe too many collisions, and it kind of still resembles Ceres. So I'm actually going to try this again, but instead use Vesta as a protoplanetary block here. So this is basically Vesta as a planet. Its mass is still not really exact, but in terms of, if we were to make this approximately the actual mass of asteroid belt as it was 5 or 4.5 billion years ago, it's about 41 masses of the moon. In terms of density and all of the other values, I have to change it, making it a little bit more realistic. So this is kind of what it would look like, at least in terms of the actual numbers. Radius of close to 6,000 kilometers, density of 3.51 grams per centimeter cube, 41 masses of the moon, and if we were to compare it to, let's say, planet Earth, let's place Earth right next to it. This is kind of around the same size, but in terms of mass, it's about half of the mass of Earth. So this particular object, which I'm going to place into our solar system right now, is what the asteroid belt was supposed to become. It was supposed to become a planet approximately half the mass of Earth, with a relatively similar composition but probably less dense due to a vast amount of water and other sort of ices that would have been on the inside of this object. So let's change the composition here just a little bit and give it some atmosphere and actually see what happens to this if it also had some atmosphere. So we know that it probably wouldn't have this much iron. It would have quite a lot of water. And we're going to give it atmospheric pressure similar to the one on Earth. So basically just 1 atmospheric pressure. And then just go to Vesta and see what actually occurs here. So right now it's just a really large ice object similar to Ceres. I don't really know if it's going to increase in temperature enough to melt this water. But I think due to the distances involved here, it's probably going to remain an ice planet. The temperature here is minus 40 degrees Celsius, and it's basically just this large ice world. If I increase the atmosphere, or if it does have more atmospheric pressure, like for example, let's say 20 atmospheres, then it does become an object with some liquid water. Maybe 20 atmospheres is a little bit too much though. How about 5? With 5 atmospheres, it already gets enough surface temperature to actually melt the water and create a water world. So had Vesta been an actual planet, and had it actually been an object in the orbit where the asteroid belt is today, it would have been a relatively large water world, assuming it has atmosphere. Now this atmosphere would be difficult to maintain because the mass here is just enough to have maybe the atmosphere similar to Mars, but not so much similar to Earth. On the other hand, it's possible that it would have had enough atmosphere, so you never really know. And this is really all I wanted to show you in this video. I wanted to create a potential Vesta planet, a planet that would have been there, would have existed in real life if Jupiter didn't have such a strong gravitational influence on the asteroid belt. Other than that, that's all I wanted to do in this video. Thank you for watching. I'll see you guys tomorrow. Space out, and as always, bye bye.